My deepest and sincerest apologies to everyone who was not able to join us for our s'mores lab today. Unfortunately, you still get to do the work of the s'mores lab without actually making the s'mores. So sad. I'll save you some supplies for when you're back. But basically, what we're going to start doing is we're going to be talking about something called stoichiometry in this next week. So we're introducing this topic of stoichiometry through something that hopefully many of you are familiar with, and that's making s'mores. So to make a s'more, you need some graham crackers, you need some marshmallows, and you need some pieces of chocolate. You roast the marshmallows, you stick everything all together, and at the end you have an ooey gooey delicious snack. So how is this going to teach us about stoichiometry? How is this going to teach us about chemistry? Well, stoichiometry is all about taking this idea of dimensional analysis that we've learned a lot about in the past, and now we're applying it to the context of chemical reactions. So what I've done is I've written a fake chemical reaction equation for making s'mores. So if we take a look at this reaction equation right here, we have S plus MM plus OR yields 1 S2 MM OR3. Okay, so the first thing that you should immediately notice is, this equation is not balanced. It does not obey the law of conservation. So how can we force it to? Well, let's put a 2 right here. Let's put a 3 right there. And just to make the ratios nice and easy in a second, I'm going to put a 1 right there. And then much better. Looks good. Obeys the law of conservation now. So the cool thing about chemical reaction equations is they give you ratios that you need to combine things together to make your products in the end. There's several ratios that you can pick out in this chemical reaction equation because the ratios compare two items. Here I can compare S to M, or I compare S to OR, or I compare S to MMOR3. You can compare any two items in here by comparing the quantity you need for each, and you do that through the coefficients. So your coefficients in your balanced chemical reactions equations give you ratios that you can then apply to dimensional analysis problems. So what this is telling us is we need 2 S's for every 1 MM for every 3 ORs, and when we combine all of these things together, we get 1 S2 MMOR3 at the end. Just for fun, think about what type of reaction this would be. You have a bunch of stuff on the left combining to make one thing on the right, so it is synthesis. Hopefully you also sighed in relief when you knew it was synthesis. Okay, so let's think about if we get a marshmallow, graham cracker, and chocolate piece, how many particles of each do we need to make a s'more? Well, to figure out this information, we have to look at the balanced chemical equation. So graham crackers are denoted by the symbol S in our chemical equation. So if we look at symbol S here, we notice there's a coefficient of 2 in front of it. What that means is we need 2 S's, 2 S particles, 2 graham crackers to make a s'more. How many marshmallows will we need? 1. How many chocolate pieces will we need? 3. And at the end, how many s'mores can we make? 1. So this is telling us these are the amount of things that we need in order to make a s'more at the end. So let's think about how we can use this information in the context of making s'mores. I'm going to rewrite the balanced chemical reaction equation right up here so I don't have to flip back and forth too much. So we need 2S, 2S plus, oh wowzers, pen is not cooperating with me today, plus 1MM plus 3OR yields 1S2MMOR3. All right, so you have 1 bag of marshmallows. 1 bag is 26 marshmallows. Seems important, I'm gonna highlight it. Based on the ratio from the balanced chemical reaction, if you had a bag of marshmallows, how many s'mores can you make, assuming unlimited graham crackers and chocolate? So what we're trying to figure out here is you always want to start by writing your question. What are you being asked to solve for? Well, I want to figure out how many s'mores I can make, but what supply am I given? I'm given that I have 26 marshmallows. So I want to figure out, based on 26 marshmallows, which is noted as the symbol MM, how many s'mores, S2MMOR3s, can I make? So I've identified my question, looking pretty good so far. How can I set up my dimensional analysis? Always start with your known. So your known here is the value that you're given. I'm given that we have 26 marshmallows, MMs. So I take this value and I put it over 1. I want to figure out how many s'mores I can make from this. So what's the ratio between the units I want, S2MMOR3s, and the units I have, MMs? For that information, I look to the balanced chemical reaction equation. The ratio is given to you by the coefficients. So for every 1 MM, I can make 1 S2MMOR3. So how can I put that into a conversion factor? How can I make it into a ratio? Think about what units need to go on the denominator. I want to cancel out units of MM. So that means that has to be the unit that goes in the denominator of my equation, of my conversion factor. So MMs are going to go on the bottom, and S2MMOR3s are going to go on the top. What's the values I need to add in? 1 marshmallow per every 1 s'more. So when you're doing these problems, always make sure you set yourself up for success by crossing out your units first before multiplying, because you want to check that you have the right units first. Otherwise, if something goes wrong there, it's not even worth it plugging things into your calculator because you know you messed up somewhere. So we're going to cross out our MMs. And this one's a little bit easy because all I have to do here is take 26 times 1 and divide by 1, which is going to leave me with 26. So my value is 26. What are my units? Well, the only units I have left, S2MMOR3s. So I can make 26 s'mores based off 26 marshmallows. Great. Now let's keep going. So in this case right here, I want to figure out how many graham crackers I need. So in this case, you're figuring out based on 26 s'mores, how many graham crackers would you need? So complete these questions right here. Check in with the answer key when you're done.